Good morning, good afternoon, and good all to all. My name is M.Gonzalez, the leader of this group.
And I'm actually A.AdorDionisio.
I'm A.Tarucan.
And I am Ivy Maris A.Centeno.
We are here to discuss the final subject of this semester, solar-powered home. Now, what is a solar-powered home nga ba?
So, ang solar-powered home ay may three configuration. First dito is yung grid tied. A grid tied solar power system is connected to the home and to the traditional electricity utility grid. This type of solar power system does not include any storage battery. So, ang grid tied daw is nakakonekta siya sa ating home or bahay and sa traditional electricity utility grid, and ang grid tied ay wala siyang battery. Unlike dito sa off-grid, this type is a standalone system that is completely disconnected from the electric power grid, and it contains a large set of battery packs which stores energy during the day to be used at night or at times when sunlight is intensity low. So unlike sa grid tied, ang off-grid ay ang grid tied ay walang storage battery. Ang off-grid ay may storage battery na pwedeng pag-storean ng mga nakukuhang energy during day or daytime na pwedeng magamit sa nighttime, and kapag yung araw ay ang sunlight ay hindi ganun kalakas. Next naman is yung pangatlo na hybrid. Ang hybrid is a grid-tied solar power system is also connected to the traditional utility power, which contains battery backup. So the addition at a battery backup enables the system to work where there is power interruption. So yung hybrid, para siya pinaghalong grid-tied, off-grid, ay grid-tied and off-grid, and para ding hindi rin siya pinaghalong grid-tied and off-grid dahil ang hybrid na solar power system is katulad siya ng grid-tied na nakakonect sa traditional utility power, and para din siyang off-grid dahil meron siyang battery na kaya mag-store ng energy. So, ito yung solar-powered home or ito yung grid-tied. In a grid-tie, the solar power system is being connected in parallel to the electric supply that goes inside the house and only functions during the day. So, ayun nga, dahil nga yung grid-tied na solar panels is na solar powered home is walang battery, hindi siya nakapag-store ng energy na nakukuha niya during daytime, kaya hindi siya gumagana kapag nighttime. And nagpo-function nga lang siya during day. Any excess energy that is being produced is then fed to the grid. Since there is no battery backup, it does not power at night. Ayun nga, tulad ng unang sinabi, dahil nga wala siyang battery backup, hindi siya gumagana kapag gabi, kapag walang sunlight. During brownout, the solar power system is also a shutdown state, hence does not produce electricity. Its main purpose is to save electricity. In fact, when the solar array's ratings matches the electric consumption, zero bill can be attained. And when solar arrays ratings exceeded the day and night electric consumption, the system will be able to produce excess power, which will be paid by the distribution utility. Next. So, ayan po yung figure ng grid-tied na solar-powered home. So, solar-powered home, ito po yung grid-tied. Ito po yung basic parts ng isang grid-tied na solar-powered home. First is yung solar panel. Next is yung grid-tie inverter. Pwede siyang with or without limiter. And pwede rin siyang square wave or pure sine wave. Next na basic part ng grid-tied is yung DC circuit breaker and yung DC surge protection device. Next din is yung AC circuit breaker and AC surge protection device. Next naman is yung time delay switch or TDS, DC or AC electrical wires, and yung MC4 connectors, solar rails, and yung clamps. So, for reference, ganyan po yung itsura ng solar panels. So ito po tayo, parts and functions ng isang solar panel. The heart of solar-powered home. Ang heart daw ng solar-powered home is yung solar panel. A typical solar cell will only produce around half a volt. So by connecting them together in series inside the panel, a more useful voltage is achieved. So ito nga, most small solar panels rated 150 watts or below are rated as 12 volts, while larger solar panels are 24 volts. A 12-volt solar panel produces around 14 to 18 volts when put under load. This allows a single solar panel to charge up to a 12-volt battery. Incidentally, if you connect a voltmeter up to a solar panel when it is not under load, you may well see voltage readings up to 26 volts. So this is normal in an open cut on a solar panel. As soon as you connect the solar panel into a circuit, this voltage level will drop to around 14 to 18 volts. So ito naman yung solar panel connections. So ayun nga, solar panels can be connected together to create a solar array. The output of a solar array is computed much like a battery. So dito nga yung series connections, nag-increase siya ng voltage while current remains the same. Unlike sa parallel connections, ang nag-increase sa kanya is yung current while yung voltage naman ay nagre-remain the same. So ayun nga, ang series, ang nag-increase lang sa kanya is yung voltage. Ang current ay nagre-remains the same. Yun naman kabaliktaran sa parallel. Ang parallel naman is nag-increase yung current while yung voltage nga ay remains the same. So when you connect multiple panels together, the power of the overall system increases, regardless of whether they are connected in series or in parallel. So dito nga meron tayong example. Each panel on the next slide is rated at 12 volts and 10 amperes. So pinapakalculate nga yung following yung total voltage, total current, and total power. So ayan yung mga figure. Unang figure is yung panels in series, panels in parallel. Tapos yung last two na nasa baba is yung panels in series parallel. Next. So ito nga yung mga nakuwang answers. Diyan yung number 1 kasi is in series connection. So ang voltage natin kanina na given is 12 volts and 10 amperes yung ating current. So ayun nga, yun nga voltage sa series is nag-increase and kaya nakakuha tayo ng 36 volts and yung total voltage natin and yung total current natin is naging 10 amperes lang dahil ang sa series connection ang amperes ay o ang current ay nagre-remains the same. So sa number 2 naman is yung parallel nga, ang given nga natin is 12 volts and 10 amperes. So nag-increase lang yung total current niya which is 30 amperes. So nag-stay the same yung ating total voltage na 12 volts. So number 3 and 4 naman, series parallel, pareho siyang nag-increase. So yung total power naman natin, mga nakuha natin total power is multiply lang natin yung nakuha natin total voltage and total current. So ayan po yung example ng monocrystalline and polycrystalline na solar panels. So may dalawang uri po ng solar panels. So ito po yung solar panel types, ang monocrystalline versus polycrystalline. So sila dalawa pinaka-common na type ng solar panel and sila lagi pinagkukumpara. And dito po tayo, pagkukumparahin po natin sila. First is yung silicon arrangement. Sa monocrystalline na solar panel, meron siyang one pure silicon crystal. Kumpara naman po sa polycrystalline na solar panel, meron siyang maraming silicon fragments na melded together. Kumbaga, sa monocrystalline, may isa siya na pure silicon. Sa polycrystalline, pinaghalo-halo siya na fragments. Sa cost naman, costing ng monocrystalline is mas mahal siya kesa sa polycrystalline. Sa appearance naman is panels have black, ano ibasa doon? Black Q?
Hue. Hue.
Ba yan, Kap?
Hue.
Uwe.
Hue. Hue. Hindi pa rin hue.
Okay. Cut ko na lang. Okay. So, sa appearance naman po, ang pinagkaiba ng monocrystalline and polycrystalline is yung appearance po ng monocrystalline is meron siyang black hue. And yun naman pong polycrystalline is may blue hue.
Okay lang yan. Goods lang yan.
Okay, okay. Cut. Okay. So, efficiency naman po is mas efficient yung monocrystalline compared sa polycrystalline. And yung lifespan po ng monocrystalline is much longer than polycrystalline. Ang lifespan po ng monocrystalline is 25 to 40 years ang kaya niya itagal. And yung sa may polycrystalline naman po is 20 to 35 years. And sa temperature coefficient naman, ang monocrystalline po ay mas lower in temperature coefficient and that makes them more efficient in heat. So sa polycrystalline naman is higher yung temperature coefficient na and making them less efficient in heat. Next. Ayun.
Uy. Cut na rito. May cut na rin eh. Saan din na yan? Stop. Share. Yun nga, next natin naman ay yung mga inverters. Yun nga, ang mga inverters ay yung mga inverters convert the DC output of the solar panel into AC, which is the standard used by all commercial households appliances. Hence, the inverter output matches the voltage within the house that is coming from the grid. Traditionally, there's usually one set of inverter in a solar system. A more recent invention that has been the microinverter. Ano nga yun? Yung mga microinverters are connected to individual solar panels so that each individual panel provides a high voltage alternating current. These setups are typically used only in grid-tie systems and are not suitable for systems with battery backups. For grid-tie systems, though costly, they do offer some significant benefits over the more traditional central inverters. Dahil nga, yung cost outweighs the benefits. Dahil kasi, pagka microinverters sa every solar panel naman nilagay mo yun, mas efficient yung makakuha ng kuryente mo. Rekta niya nang i-convert. So, mas ma-efficient in the long term. Siguro yun. A grid-tie inverter nga, unique characteristic over the other types is it automatically shut down the system when there is a power interruption. Yun lang ang pinagkaiba niya sa ibang types na sa hybrid at saka sa stand off-grid. Sa off-grid. Ang types, dalawa lang ang types ng inverter. Pure sine wave at ang modified sine wave. Yung pure sine wave outputs voltage in the form of a sine wave. Utilities also provide sine wave output. Because of this, pure sine wave inverters are usually needed if you're going to be tied to the grid. Typically, you'll need pure sine wave inverters for sensitive equipment, newer TVs, CFL, light bulbs, and appliances with AC motors, kumukha ng microwaves and refrigerators. Pure sine wave inverters are capable of producing cleaner, smoother, quieter, and more reliable electricity to operate appliances and electronics without interference. Renoging sells a variety of pure sine wave inverters of varying capacities to fit your solar installation and your electricity needs. Yun yan. So bakit ba may modified sine wave? Kung may ganyan pa siya, no? Diba? Explain naman natin ang modified sine waves. Modified sine waves, yun nga, unlike ng pure sine wave inverters na nagproproduce by the inverter very closely, ito naman mga closely matches an actual sine wave. In modified sine wave inverters, the polarity abruptly switches from positive to negative. When looking at the wave, it has a stair-step square pattern where the polarity is flipped back and forth. Yung choppy wave na yun can negatively affect more delicate sensitive equipment. Additionally, in many cases, you'll hear a hum in devices attached to a modified sine wave inverter. The only advantages this type over the pure sine wave is that mas mura. Yan, no? Nakita mo naman, no? Yan. Tataas, bibiglang bababa, bibiglang tataas. Unlike dun sa pure sine wave na talagang diretso. Ang personal masyado ng tao mo, bibili pa ng modified dahil cheap siya. Kung di mo namang gagamitin sa kuwari, mga delicate equipment like the CP-AP machine. Yun ang use no. Mga ratings naman ng inverter ay acquired through using two variables. A continuous watts is the total amount of watts the inverter can support indefinitely. A 2000 watt inverter can power up to 2000 watts continuously. A bigger inverter size could handle more. Yun nga. Yung continuous watts naman na rating is using what the solar panel can output, the solar array, I mean. So kung 2000 watts ang na-output niya, 2000 watts ang minimum. You can have more pero the efficiency will drop if the rating ng inverter ay masyadong malaki. So naman doon yung surge watts. It is the amount of power the inverter can support for a very short time, usually momentarily. So yun nga, 2000 watt inverter rated up to 4000 surge watts can handle up to 4000 watts momentarily while starting things like motors. Yun yan. Ang surge watts naman ay yung binabasihan po sa mga kailangang malaki ang open kumuha ng motor, yung aircon, malakas sa umpisa yan, ganun. Mga bagay na kailangan ng energy in a very short time. Next naman din, DC circuit breakers. Sino na? Oh, maghintayan tayo rito.
Ako na pala. The next is the part of functions of the DC circuit breakers. This is the example of This is the example of DC circuit breaker or direct circuit breaker. Next. DC circuit breaker refers to the circuit breaker used in DC power distribution system, generally applicable to solar photovoltaic power generation and power distribution system, battery energy storage system, new energy vehicle, DC charging system, etc. Yung DC circuit breaker daw ay tumutukoy sa mga circuit breaker na ginagamitan ng direct circuit power of distribution system. Ang karaniwang, yun nga daw yung mga karaniwang naangkop. Ang mga karaniwang naangkop nga daw dito ay ang mga nasabi ko kanina, yung mga battery energy storage system, new energy vehicle DC charging system, at marami pang iba. And the next is a system in which the input power supply terminal of the circuit breaker is direct current. Ang DC circuit breaker daw ay isang sistema na kung saan ay input power supply terminal ng circuit breaker ay direct current. The next is the general DC circuit breaker include DC MCB or direct current miniature circuit breaker, DC or DC MCCB or direct current molded case circuit breaker, and type B RCD or residual direct device. It may also serve as a manual switch if there is the need to turn the solar power system off isolate solar panel from the rest of the system. Ang ibig sabihin nito ay maaari daw itong magsilbi bilang isang, yun nga sinasabi na mano-manong switch na kung may pangailangan na patayin ang solar power system upang ihiwalay ang solar panel mula sa natitirang bahagi ng isang system. Next, the parts and functions of AC circuit breaker. RCBO type. This is the example of the AC circuit breaker or in RCBO type. The AC circuit breaker are placed after the inverter. Yung AC circuit breaker daw ay naka-place siya bago pagkatapos ng inverter. Just like a typical circuit breaker, it acts an overcurrent protective device due to short circuit and overloading. Yung RCBO daw is stand for the residual current operated circuit breaker with overcurrent protections. And in the RCBO types, it has added protections. Yung RCBO types naman daw ay nag-add siya ng protections. And since it can sense earth leakage current where the typical breaker cannot, it has the capability to trip when somebody touch a live wire, thus protecting the people around it. It may also serve as a manual switch if there is a need to turn the solar power system off. The next is the part of functions of DC surge protections.
Sino naman?
So, ayun po ano. Solar powered home grid type part and function. DC surge protection device. The DC SPD are placed parallel to the DC.
Ganun yung boses mo? Parang kulog. Parang nasa cabin. Kulog. Ganun.
Ayan. Ano lagay?
Ganun din eh. Parang kulog eh. Ayaw ko. Okay na din. Parang yung nag-e-echo. Hindi echo yun. Walang kung natawag sa ganyan. Ganun na rin yun. Yung parang...
Next is solar powered home grid type. DC surge protection device. The DC SPD are placed parallel to the DC CP. So, SPD generally protect the system from power surge or more appropriately called voltage transient. So, ang DC surge SPD, ito is, in-offers niya is protection. So, ano ba yung, ano na yan? So, it protect the system against power surge. So, ano ba yung tinatawag nating power surge? So, ang power surge is yun yung transient voltage na usually na nakukuha natin sa mga catastrophic, caused by catastrophic. So, ano ba example ng mga catastrophic like lightning? So, dahil doon nagkakaroon tayo ng transient voltage o yung biglang pagtaas ng voltage. So, na pwedeng makasira ng ating mga system. So, ang DC surge protection device bago pumasok sa may sa ating mga system, pinipigilan niya yung biglaang pagtaas ng voltage dahil nga sa catastrophic na tinatawag. So, ayan. So, ang DC surge, nasa ano siya, DC, nasa DC side siya ng connection. So, SPD redirect this excess power to the ground. In PV system, since solar panels are heavily exposed in the environment, transient voltage is primarily caused by a lightning either directly or indirectly. Multiple interconnection with power cables is very susceptible to electromagnetically induced transient where power surge could also arise. So, ayan nga yung mga sinabi natin kanina. So, transient voltage is the occurrence of a very high voltage in a very short duration of time, around 10 to 100 of microseconds. So, ganun lang siya katulin, yung power surge na yan. Around 10 to 100 of microseconds. So, exposed to this transient voltage may cause to a catastrophic component damage, leading to system failure. Ito ay nakakasira ng, pwedeng makasira ng mga system natin. dahil sa catastrophe. Pag wala tayong DC surge protection, may mga possible na masira yung ating system. So kaya natin nilalagay ito para mapigilan niya yung pagtaas ng bigla ng voltage dahil sa mga lightning. Ganun. So, AC surge protection. So, yan siya. So, yung basta AC po yan So, AC surge protection device. So, pareho lang din siya. Ngayon naman nasa AC side naman siya ng connection. So, parehas lang din sila ng ginagawa para ma-control yung transient voltage o yung biglang pagtaas ng voltahe dahil sa catastrophe. Okay. Next is solar-powered home grid type part-time function time delay switch. So, ano ba ginagawa ng time delay switch? So, a time delay switch or TDS is a switch which is linked to a timer allowing the user to delay on-off cycles of the switch. This can also be called as power on delay. It delays the turning on of any electronic device for a desired time interval. This device serves its useful purpose usually when brownout occurs. After a brownout, when power have already been restored, there is the tendency of power surge which may damage the system if it is being turned on right way. To prevent this time delay, switch delays the turning on of the system for a minute or even a bit more. So, yun yung time delay switch, so yun yung ginagawa niya, dine-delay niya yung pag on or off ng ating system. Like for example sa mga sa ano natin sa bahay, like for example sa TV natin biglang nawalan ng kuryente. So di ba most laging sinasabi sa atin yung tanggalin yung saksak para pagbukas hindi masira yung system. So totoo 'yon. So kasi pag biglang pagbukas ng kuryente, meron tinatawag na power surge. So, yun nga yung biglaan din pagtaas ng voltahe na pwedeng makasira ng ating system. So, ganito rin yung, so, itong time delay switch, ito yung purpose niya sa may, sa ating solar panel. So, pag on mo kasi ng system ng solar panel, may possible kasi magkaroon ng power surge o yung, ayun nga, biglang pagtaas ng voltahe na pwedeng masira yung system nga natin yan. So, kailangan nating ng time delay switch para pag binuksan natin yon may duration siya na mga ilang segundo bago siya unti-unting mag-flow yung pagbukas niya. Dahan-dahan siya magbubukas. So, yun. Dahil doon, may iwasan natin yung magkasira yung ating system. So, next is programmable timer. So, yung example nun. So, turning the solar panel system on and off could be a vital routine which cannot be perfectly on a day-to-day basis. Programmable timer is a hassle-free switch that automatically turn the system on and off at your desired time. So, dito kasi sa Pilipinas, alam naman natin na may time lang na yung peak yung araw. So, imbis na manually turn and off natin siya. So dahil dito sa programmable timer switch, napapadali niya yung buhay ng taga-on off. So dito isa-set niya lang na kunyari like alas 11 and mamamatay siya ng alas 5 o alas 6. So yun yung ginagawa ng programmable timer switch.
Next naman nga doon is net metering o yung idea ng net metering. So ano nga ba yung net metering? Net metering allows customers of distribution utilities or DUs to install an on-site renewable energy facility not exceeding 100 kilowatts in capacity so they can generate electricity for their own use. Any electricity generated that is not consumed by the customer is automatically exported to the DU's distribution system. The DU then gives a peso credit for the excess electricity received equivalent to the DU's blended generation cost, excluding other generation adjustments, and deducts the credit earned to the customer's electricity bill. So yun nga, kung meron ka naman ding solar array na solar power system, bakit kailangan mo nga naman na hindi mo naman susurohin mo lang yung kuryente. Pwede mo nang i-share. Share mo yung electricity mo. Huwag ka naman madamot. So, is net metering nga ba available sa Pilipinas? Of course naman. Noong 27th of May 2013, the Energy Regulatory Commission adopted the ERC Resolution 9 series of 2013 approving the rules enabling the net metering program for renewable energy. This resolution was published on 10th July 2013 in newspapers of general circulation in the country and took effect 15 days thereafter. Kailangan ng 15 days for mga ganyang bagay to effect siya. Thus, the net metering rules took effect in the Philippines on July 24, 2013. The net metering program is available only on on-grid distribution systems or DUs connected to the transmission grid. Siyempre nga, kung hindi ka naman naka-connect sa transmission grid, so paano ka makipag-share? Hindi mo naman pwedeng magdala ng baterya sa mga DU mo. Hindi ka pwedeng magdala ng baterya sa NECO, sabihin mo, kuryente, bebenta ko sa'yo. Hindi naman pwede yun. Ano nga ba ang benefits nito? Siyempre, by generating electricity for your own use, you reduce the amount of electricity you buy from your local DU. The rate of saving or avoided costs realized on electricity generated for own use is equivalent to the DU's retail rate, consisting of charges for generation, transmission, system loss, distribution, subsidies, taxes, and other, etc. etc. You also earn peso credit on any kanina ko na-explain. Yun nga, ang benefit, magkakapera ka, magkakaroon ka ng mare-reduce yung electricity cost mo, di ba? Win-win naman. Bibigyan mo sila ng kuryente, mababawasan din kuryente mo, di ba? Ganda. How will my DU meter my import or export energy? Yun nga, the DU may opt to install two unidirectional meters, one to meter energy you buy from your local DU, and the other to meter the energy you export to the DU. The DU may also, it's option to install a single bidirectional meter that can meter both import and export energy if it finds to be more economical na. Pare, kung poste nyo naman mga wala naman nakalagay doon, pwede naman 2 metro na. Ang dami espasyo doon. Kung ang liit naman din nung tore nyo, ang tore nyo, poste nyo mga punong-puno na ng mga metro. Siyempre, pwede na yung 1 meter na lang na mamahalin ng hotel. Diba? The DO may also install a third meter in proximity to the renewable energy facility. The meter is total renewable energy generation. A total RE generation shall earn for the host DO RE certificates which the DO can use to comply with its energy renewable portfolio standards or RPS obligations. Wow! Nagamit tayo para makakuha ng certificate. No? Sino ba ang qualified dito? Everyone. Sure. The DO customers who are in good credit standing in the payment of their electrical bills to their DOs are qualified to participate in the net metering program for renewable energy. Siyempre, kung hindi ka naman nagbabayad kasi nagpagawa ka ng renewable energy, hindi sila matutuwa dun. Hindi ka naman nagbabayad. Bibigyan pa sila ng bill. Ikaw sila pa magbibigyan. These customers are referred to in the rules as qualified end users or QE. Ano ba ang consequence ng hindi mag-net metering? In the case na solar power system is being installed and doesn't apply for net metering, any excess energy that is being fed to the grid will be also billed to the customer. Example nito nga is, yung system is 5 kilowatts rated and the load consumption is only 4 kilowatts. Okay. The system will have an excess of 1 kilowatt which will be sent to the grid. Yung excess energy to, dadaan sa metro at mabibill pa sa'yo. Instead na the other way around. No? So kung sobra naman nga, dadaan din yun sa metro. Hindi naman yan alam ng metro na kung papunta palabas naman yun, hindi naman ganda ng metro naman. Hindi naman automatic, hindi binigay. Isang question pa ulit. Is there any way, besides net metering na customer na solar power system, producing excess energy during the day and yet will not pay for it? Siyempre meron. Ang daming solusyon sa lahat ng problema. Ang solusyon doon, maglalagay ng limitary inverter. This device limits the power that the system will dissipate. It automatically detects the maximum power that the system can provide without excess being sent to the grid. Yun nga lang. No? ika-cut off mo lang yung kuryenteng lalabas sa inverter, papunta sa system, papunta sa grid. Next naman ang kailangan sa solar panel system, sayang wire types. Ano ba ang mga wire types? Maraming wires. May mga copper, zinc, aluminum, etc. etc. Pero for now, mga electrical wires na siya. Ang first type naman natin is thermoplastic wires or TW, which are moisture resistant and flame retardant. It is used in interior housing wiring and circuit voltages up to 600 volts, suitable for the type of service where conductor temperature does not exceed 60 degrees in dry or wet locations. Yun yan, hindi naman siya effective sa maaraw dahil 60 degrees. Baka konti lang din yan. Masusunog, masusunog na halos mga kabo doon sa taas ng bubong. Sunod naman doon na thermoplastic heat resistant wire or THW, which is mostly used in interior house wiring and etc. where temperature does not exceed 75 degrees Celsius. Yun nga. Isa din siyang moisture resistant and flame retardant nga. Thermoplastic siya, na heat resistant din siya, di ba? Mas matibay siya, pero hindi pa enough para sa kailangan natin. Sumunod naman dito ay THHN or thermoplastic high heat resistant nylon coated wiring na designed for specific insulation material, temperature rating, and condition of use suitable for dry and damp locations. Type THHN or THWN or THWN2 are primarily used in conduit and cable trays for services, feeders, and branch circuits in commercial or industrial applications. Ito na nga, yung mga pang malalakihan na pang industrial. Kanina yung mga THN, THW, TEW, mga pambahay lang yan. Ito mga THN o THWN, mga pang business na yan. No? Note nga lang natin na THN is only used not exceeding 90 degrees Celsius. With THWN can be used in wet locations not exceeding 75 degrees Celsius or dry locations not exceeding 90 degrees Celsius or locations not exceeding 75 degrees Celsius when exposed to oil. Yun yan. Or yung THWN2 can be used in wet or dry locations not exceeding 90 degrees Celsius or locations na exposure sa oil na pero din not exceeding 75 degrees Celsius. Baka komplikado, no? Dami na ganun, no? But still, ito ang gagamitin natin sa solar systems. Ang THHN or THWN2. THWN is similar to THHN, except it is water resistant, adding the W into the acronym. The THWN is rated up to 165 degrees Fahrenheit or 75 degrees Celsius in wet environments. But its successor, THWN2, is rated for 90 degrees in both wet and dry locations. So yun ang ginagamit din THHN, THWN, THWN, dami na. Basta yun na. Historically, THHN and THWN were separate wires, but now you'll typically find their capabilities combined in the THHN, THWN2 design. Yan. Ito nga. The T stands for thermoplastic insulated cable. Kanina sa daming T. No? A single H means that the wire is heat resistant. The long H means that the wire is heat resistant and can stand a higher temperature. Na. High heat, diba? H, double H. No? The W signifies the wire is also resistant to water and may end din na nakakoted siya sa nylon. Easy no? Daling intindihan. TH, H, H, puro ganun, no? Okay, next naman ay yung photovoltaic wires. This type is an exclusive type of wire created for photovoltaic applications. These cables behave extremely well in very hot temperatures and other harsh environmental conditions. Its special characteristics compared to other wire is its installation in outer sheet which is made out of XLPE or EPR. Makatibay. Hindi ko lang kanya, pero matibay siya. XLPE is an acronym for cross-linked polyethylene. XLPE is a thermosetting polymer, meaning that its material or polyethylene is cured under heat and in the process forms bonds in all directions, forming a three-dimensional matrix. EPR means ethylene propylene rubber. Ganun, no? Naintindihan ko yun, man. Next naman dito ay ang American Wire Gauge or AWG. The AWG is a standardized wire gauge system for the diameters of round, solid, non-ferrous, electrically conducting wire. The larger the AWG number or wire gauge, the smaller the physical size of the wire. The smallest AWG size is 40 and the largest is 0000 or 4/4, 4/0. AWG general rule of thumb is for every 6 gauge decrease, the wire diameter doubles, and for every 3 gauge decrease, the cross-sectional area doubles. Note natin na the W and M wire gauge, US steel wire gauge, and US wire gauge are different systems. Pero ang ginagamit natin ito ay AWG. You can see here na nga, so, then, yun na, different. Nakita dito, 40, ang pinaka, sabi nga, smallest na, 40 AWG. As yung nakita no, 80, no? Pakadami. Ito pa, mas clear na. Yung 12, ayun, ganun lang, paliit. Yung 12. Ito yung 10, mas mataba, tapos yung 8, tapos 6, 2, 0. Laki ng pinagkaiba. Pabaliktad ang numbering. Next, punta naman tayo sa mga tables na gagamitin for the wire sizing computations. First table is the table 310.15b16, or the allowable capacitance for insulated conductors rated up to and to including to 2000 volts, 60 degrees to 90 degrees, marami pang salita. Basta yan mahaba na yan is for the conductor capacities. Ito yun. For example natin, sabihin natin na 10, size 10. Sa size 10 in 60 degrees na ginagamit doon ay TW or UF, ang capacity niya lang in those things is 30 amperes. Sa 75 degrees, 35. Sa 90 degrees, 40. Ganun lang. Ganda ng table. Eh, marami pa. Ito yung dami-dami. Ang dami. Dami ng mag-move ng table. So, doon naman ng table 310.15b to A, or yung ambient temperature correction factors in mga specificness. In this table naman na, alam natin kung ano yung ambient temperature na, kung base sa ambient temperature nito, may dadagdag tayo na rate, dadagdag tayo sa multiply in the ambient temperature to decrease the ampacity of the wire. Example natin is like 21 degrees in 90 degrees in the 90 degrees wire. Ang re-reduce nun is 1.04 na konti lang din pero it's still there, di ba? Next naman dito yung mga table 310.15b3c, or yung raceway in cables exposed to sunlight on rooftops. You can see yun nga, ang daming tables na yun. Mayroon version ng 2011, mayroon version ng 2014. Nung unti lang ang pinagkaiba nun, but still, pareho lang ata sa pareho lang. Iba lang yung sa 30 minutes, may mga 90 minutes. So, yan lang din. Pero ngayon, base sa nabasa ko, noong 2017, may bago ng table na yung ito. Example nito is on the desert rooftop, the outside temperature is 100 degrees Fahrenheit. Since the raceway is not at least 7/8 inch above the roof surface, a temperature adder of 60 degrees Fahrenheit must be added. Yung ang average temperature naman yun is 160 Fahrenheit for the purpose of the rating the wire. Bakit ba ganon? Maraming rason.
For several code cycles, table 310.15 B3C provided ambient temperature adjustment factors for raceways or cables exposed to sunlight on or above rooftops. The table provided numeric values to be added to the normal ambient temperature based on how close a raceway or cable was to the hot roof surface. The further away the wiring method was from the rooftop, the smaller the temperature adder was. The concept was this writing method exposed the sunlight and very close to the roof surface, while the hotter than a wiring method with a bit distance from the rooftop. The closer the wiring method is the roof, is to the roof surface. The more indirect heat is reflected back to the writing method from the roof surface. As the wiring method gets hotter, wiring in the raceway or cable cannot continuously carry to the some ampacity and must be derated. The issue of ambient temperature and correction factor others for raceway and cable assemblies installed above the rooftop has been seriously debated by Code Panel 6 for several cycles in the 2017. A code change proposal from a special task group was accepted to delete the cable. The task group was assigned to review the facts surrounding the initial testing for rooftop firing method that resulted in the table being added to the NEC in 2008. The special task group found two substantial data that warranted the need for the table, even though the overall table was deleted. One of the previous temperature, others still remains within the revised text of the code section. Now the rule is simply this: where raceway or cables are exposed the direct sunlight on or above rooftops, raceway or cable shall be installed a minimum distance above the roof to the bottom of the raceway or cable in 7/8 inches. Where the distance above the roof to the bottom of the raceway is less than 7/8 inches. In temperature other of 60°F shall be added to the outdoor temperature, determine the applicable ambient temperature for application of the correction factor to the table 310.15 of B2A or table 310.15 of B2B.
Thank you. Yeah. Ano yan? Sorry lang na muna ko sa habang ngayon. So, naman, so then the table naman natin is table 310.15 B3A or yung CC count adjustment factors. Ito naman ang adjustment factors for more than 3 current carrying conductors in a raceway or cable. As you can see here nga, di ba? In a 4 to 6 conductor cable in a single conduit, ang percentage lang ng conductor capacity niya is 80%. Bumaba, no? Kung apat o anim yung cable. As if, mas marami, mas pababa yung capacity. Yun lang yan. Note nga lang natin, no? Ngayon, in K is the direct current constant, or this is the current constant representing the direct current resistance for a 1,000 circular mil conductor that is 1,000 feet long and an operating temperature of 72 degrees Celsius. The direct current constant value you should use for copper is 12.9 ohms and 21.2 ohms for aluminum conductors. The K constant is suitable for alternating current circuits where the conductor don't exceed number 1/0. Next is sino ba dito? Diba?
Nawata dyan. Ako pala gumawa dyan.
Ikaw nga ata. Pakaputi, sakit sa mata. Pakaitim ng lahat ng gawa namin pag na nagputi.
This is the DC circuit breaker sizing. First thing to consider in sizing a circuit breaker for PV system in the ruling in PEC, which state that PV circuit current is continuous. Thereby, the minimum OCPD rating is 1, yung minimum OCPD rating daw is 125% of the 125% of the maximum current. PEC 2017 Article 6.90.2.2 B and Article 6.90.2.3 B. Therefore, it refers to the problem in conducting and therefore, this is the reference of problem in conducting sizing. On the DC sides, the max current is 1523 ampere. Yung DC side daw, yung max current daw is 15.23 ampere. Multiply by 125%, that is 19.03. Use
04.
ah
04.
19.04. Use 25 ampere circuit breaker. On the AC side naman, let's assume the inverter rating is 1.5 kilowatts and the current of 12 ampere. Multiply by 125%, that is 15 point AC. Use in 20 ampere circuit breaker in RCBO type. This is the circuit breaker sizing. This is the standard ampere rating. From 15.
Yan yung table.
This is the table of the circuit breaker sizing.
Yun lang. Yan, item mo. Item.
Sa akin pa rin ba to?
Hindi.
Hindi na sa akin.
Kay Ash na ata ba?
Hindi sa akin yan.
Oh. Sarap sa mata. Item. Ashi, Ador, ata
So
sa...
next is solar-powered home grid type surge protection device sizing. The rule is simple in sizing of surge protection device. Basically, the UC rating of the SPD should match the system voltage or a bit higher, 15% to 25% for SPDs to attain a longer lifespan. Therefore, in reference to the problem in conductor sizing, for the DC side, you use SPD with UC rating of 100 volts to 120 volts. And for the AC side, use SPD with UC rating of 230 volts and 275 volts. Kaya niya. SPD specs in nominal discharge current. Maximum discharge current and UC maximum continuous operating voltage or MCOP and up voltage protection rating BPR or surge voltage rating or clamping voltage. So next is solar powered home zero bill computation. So dito sa solar powered home grid type zero bill computation. So like for example, ang first na gagawin is complete nyo yung monthly average kilowatt hours na nakukonsumo nyo. So ang example natin is 300 kilowatt hour monthly. So ngayon, convert to daily usage. So 300 divide 30 days. So may 30 days tayo sa isang buwan. So magiging 10 kilowatt hour per day ang nakukonsumo natin. So ngayon, i-convert natin siya into watts para maging kamukha nung rating nung ating solar panel. So magiging 10,000 watt hour per day ang ating nakukonsumo. So dito, sa Philippines, makikita natin ang peak sun hours natin. So dito, ang kalimitan, makikita natin around 4.5 to 5 and 5 to 5.5 lang yung pinaka ng araw sa atin, peak ng araw sa atin. So ayan, so ang peak sun hours dito kalimitan is 5 hours. So, ayan, 5 hours a day lang. So, for solar array rating, yung nakuha nating 10,000 watts per hour, so di-divide natin yon sa may 5. So, ang ano nating oras. So, pag dinivide natin yun, so magiging 2,000 watts. So, dito sa may pag solar panel, hindi naman kasi saktong mako-convert. Hindi naman sakto na lagi yung mako-convert na araw kasi di naman natin mape-predict kung kailan kung gaano katagal yung araw o kung kailan so mag-add tayo ng another 10% para kumbaga assurance lang. For zero bill assurance lang. So nag-add tayo ng another 10%, so magiging 2 times 1.1, so magiging 22 watts na siya. So ayan. So ngayon yung nakuha nating 2,200 watts na to, i-divide lang natin sa 300. So yung yung nakuha nating 300 kilowatts hour per month na yan. So di-divide natin yan. So ang lalabas 7.33. So wala naman 7.33 na na panel. So i-round up na natin siya into 8. So 8. So magiging 8 solar panel na siya. So yung sobra-sobra na siya para ma-attain natin yung zero bill assurance.
Ito nga, itong ginawa ko para itong para system natin. Yan. Yan. Ito galing sa solar panel, yung kuryente galing from the solar panel nga ito. Pupunta siya sa circuit breaker, pupunta siya sa inverter. Pero may kuryente din pupunta sa surge protection device na kung may mag-surge, power surge, nare-recta na siya sa ground para hindi na siya mapunta sa system. Yung kuryente sa inverter, pupunta sa timer na magta-time, may delay, magde-delay ng 1 minute. Tapos yung kuryente na yun, either pupunta siya sa surge protection device o pupunta sa circuit breaker. Yung sa surge protection device, edi mapupunta na siya sa ground kung may sumobra. Sunod doon yung circuit breaker yun. Tapos pupunta sa board, pupunta sa mismong lahat.
So, yung magiging overall rating po ng ating solar-powered home is 1 kilowatt. So, ito po yung individual panel and rating and connection. So, ito po nakita namin yung pwede namin i-purchase na solar panel. Bali, ang gagawin po namin connection sa solar panel is series connection. So, ito po solar panel na nakita namin is 100 watts po per solar panel. So, para po ma-achieve namin yung 1 kilowatt na solar panel, kailangan po namin ng 10 na nitong solar panel na ito. And ito po solar panel na ito is monocrystalline solar panel.
Ganun niya. Itong mga bagay na tungkol sa panel, isa siyang yun nga, monocrystalline, sabi nga ron. Monocrystalline, it has a maximum power of 100 watts. Meron din siyang open circuit voltage na 22.6 volts and short circuit yan ganon, etc. Hayaan na natin yung 10 milliamp. Sunod naman doon is
so monocrystalline solar panels. Monocrystalline solar cells are more efficient because they are cut from a single source of silicon. Polycrystalline solar cells are blended from multiple silicon sources and are slightly less efficient. Thin film technology costs less than mono or poly panels, but is also less efficient. So, katulad ng nabanggit ko kanina na pinagko-compare natin yung quality ng monocrystalline and polycrystalline, monocrystalline na solar cells is more efficient nga dahil galing siya sa isang source ng silicon, unlike sa polycrystalline na blended siya from multiple silicon. Monocrystalline solar panels have the highest efficiency in comparison to any other type of solar panels. They are space efficient and require the least amount of space as compared to their counterparts. Monocrystalline solar panels have a higher lifespan and tend to function quite longer than their warranty period. Monocrystalline panels have the highest efficiency rating of any type of solar panel, reaching over 20%. This means that this can convert 20% of sunlight into usable energy. Polycrystalline panels are within the average range, hitting around 15 to 17%. So sinasabi lang namin dito na Ang monocrystalline solar panels, yung mas pipili naming type ng solar panels to work with. Kasi nga, katulad nga nung pinagkukumpara namin yung monocrystalline tsaka polycrystalline kanina is mas efficient ang monocrystalline, siya yung may highest na efficiency. And yun nga, space efficient din siya. And mas mahaba yung lifespan ng monocrystalline unlike sa polycrystalline. And ang monocrystalline din is may highest efficiency ng type ng solar panel na merong 20%. So, and find the best solar panels for your home. Dito natin makita yun na kita namin na top 3 brands na pwede naming top 3 brands na ng solar panels. So, una nga dito yung SunPower. Meron siyang panel efficiency na 22.8% and may temperature coefficient na 0.37%. So, ang next naman is na brand is yung LG. And meron siyang panel efficiency na 22.1%. May temperature coefficient siya na 0.39%. And lastly, ito naman yung brand na REC. Meron siyang panel efficiency na 21.9%. And meron siyang temperature coefficient na, mali po ito. Ito po ay 0.37%. Hindi po siya negative 0.37%. So, ayun nga po, dahil nasa Nueva Ecija po tayo, ito po yung mga nakita namin na available na solar panel stores dito sa Nueva Ecija. Una po dito is yung Omega Solar PH, na address po niya is dito po sa may Santa Rosa, Nueva Ecija. Next po is yung Solar Sales Center, dito po sa Cabanatuan City. Pangatlo naman po is yung SJ Renewable Energy na matatagpuan po sa San Jose City, Nueva Ecija. And lastly is yung Astral Power System Incorporated na makikita po natin sa Cabiao, Nueva Ecija.
These 10 solar panels, each with 100 watts rating in the system, an inverter with 1,000 watts is required. Yeah, di ba? Total, sabi niyan sa kanina na continuous rating na kailangan at least minimum yung mismong rating ng solar panel. With siyempre, ang surge rating naman niya dapat is at least 2,000 and such. Ito naman ang mga brands of choice ko naman for solar inverters. First naman is Solar Edge. Solar Edge inverters have become increasingly popular in Australia, the US, and all around the world in the last few years due to the unique design using DC optimizers which enable individual solar panel level of power optimization and control. Sila nga, mga kakaiba sila, marami silang magagaling sila eh. Kaya nauna kong choice ang Solar Edge. Dahil nga sa DC optimizers, yun nga, small electronic modules attached to the rear side of each solar panels, which enable each panel to operate at maximum power level. Yun nga, especially yung mga microinverters, kaya maganda rin yung mga gawa nila. Siyempre, meron din ang solar system monitoring nila have the optional Wi-Fi, which together with the optimizers will provide power output data for each panel individually. Maganda nga siya na for both system monitoring and a very good tool for fault detection na. Alam mo kung sira isang solar panel doon, isa doon. Also, Solar Edge definitely have one of the best smartphone apps for the remote system monitoring. No? Sunod doon ay Fronius. Fronius inverters have maintained the top spot for much of the last 8 years, ever since the release of the innovative Snap-in design in 2012. These Austrian manufactured inverters have become the inverter of choice for many domestic and commercial solar installations due to their proven performance and reliability, plus the great service from the Fronius support system. Magaling support system nila, magaling. However, the high demand for the popular single-phase Fronius Primo inverters used in there have been some minor faults. Hindi siya ang first. Meron din siyang mga active cooling system, which is ayan. At saka yung pinaka-ayaw ko nun, kaya hindi ito yung first, ay yung system monitoring nila. Yung system monitoring nila is, yes, okay, pero premium siya eh. It can only be used for 3 days na tapos susunod may 3 days of consumption monitoring data can be accessed without a premium subscription to the Fronius Solar Web. The premium upgrade offers some great features, but considering most competing platforms offer free usage and generation history, disappointing nga siya na libre naman siyang binibigay sa iba, pero dito, may bayad. Sunod na ng SMA. German manufacturer SMA Solar Technologies was widely regarded as best string inverter manufacturer before the Frontnew snap-in series took the top spot in 2016. Yun nga, magaling sila. Pero local services support is excellent nga. And SMA provided optional 10 to 20 years extended warranty. Marami silang maganda. Like many other new inverters, the latest 8 inverter series from SMA doesn't have the display and relies solely on Wi-Fi communication for setup and monitoring. Yun ang rason ko bakit naging pang-clock siya. Pero maganda rin siya. Ano siya? German. Diba yan? Monitoring nga yan. Online na free. Diba? Free. Kaya yun ang choice ko na. Ito kung mag-tutuloy man yung gagawin namin. Ito ang napili ko. Yan. Solar Edge SE100M, 1000M, which costs 457 euro sizing computation. Paano nga ba ang gagawin natin sa wire sizing computation ng system natin? Ang una, maghanap ang ICS rating ng PV cell natin. So now, then multiply by 2 safety factors yung irradiance and continuous duty. Sunod, mag-refer tayo sa table 310.15B146 na size ng wire. Sunod doon, magre-refer tayo sa table 310.15B2A for ampacity correction due to ambient temperature more than 32 degrees. Susunod naman doon, table, madaming table, puro table. Basta puro table, i-refer doon, tapos re-adjust po. Mag-a-adjust, tapos adjust, hanggang makakuha namin yung value kailangan para malaman na kung tama ba yun o hindi. Sunod, unang-una, maghanapin yung ICS rating na wala pala dito yun. Unang-una, hanapin natin ang ICS rating ng solar, mga cells. Since nga yung mga solar panels na naka-series, isa lang ang value nila. Ngayon, na nakita natin sa apakaliit pala na ito. Ang ICS rating, ISC rating ay 5.9 amps. Yun ang magiging value natin sa ang current ng mga photovoltaic cells. Susunod, multiply by 2 factors, irradiance and continuous duty, na para safety measure lang. Ang measure, siguro mga 25, mga dagdagan ng 25% for assurance. So, multiply yung 5.9 amperes to 1.25%. Yan. Tapos makuha natin 9.22 amps. Exactly 9.21875%. Sunod, refer tayo sa table 310.15B16 for size of wires. Ang gagamitin natin ay number 10 at ang sa parehoras. Number 10, THN wires whose capacity is 40 amps since na yung number 14 is not suitable for solar panel installation and usage. And yung number 12 has a voltage drop percent ng 3.14. Nakalculate mo naman. Susunod doon is titingin sa table there for the ampacity correction due to ambient temperature. Since yung ambient temperature ng Pilipinas is 37% Celsius, degrees Celsius, mainit naman lagi dito. So, siguro naman 37 na yun. No? Basta sa table, indicate na 0.91. So, multiply 0.91 sa 40 amperes. Malalaman natin na ay 35.4 amperes na reduce na yung opacity ng wire. Sunod naman, adjustment temperature due to roof wire distance. For 1.5 inches above roof, nadadagdag doon ay 22 degrees Celsius. So, ang total is 59 degrees Celsius na babawasan na naman sa opacity ng kanina 35.4. So, since na dalawang wires nga lang dahil naka-series tayo, so dalawang di magiging 3 or more yung wires sa conduit. Mapabypass na lang step 6 which is calculation ma-reduce in percentage yung wiring opacity. Sunod, adjustment due to voltage drop. Ang voltage drop dapat ng wiring ng power is not less than 3%. Using this formula, VD equals 2IR, which is Ohm's law na VIR, di ba? Yung R dito is yung K, which is the direct current constant, L yung length ng wiring, and A yung circle mils ng wire. So as you can see na 2 multiplied by I, yung I natin is 5.6 yung kanina. K, which is a constant 12.9. Yung length na ginamit natin is 25 meters, for example, na di namin calculate. Ayan, mahaba ang bubong. At yung A, which is 10,380 mils, which will give us a 0.35 volts na voltage drop. To calculate the percentage, we divide that simply by the 17.6 volts na na-output ng solar panels, which will give us 1.98% of voltage drop, which is well below the 3% requirement.
Ngayon, titingnan natin kung, kakalculate natin kung ano ang kailangan surge protection device rating natin. So, dahil sa solar panel natin, ang DC natin, o yung maximum power voltage natin is 17.6. So, dahil naka-series tayo, i-multiply natin yun sa 10. So, equals, magiging 176 volts na yon. So, ngayon, para pang safety precaution o yung for more efficiency, magdadagdag tayo ng around 20% para for more efficiency. So, pag kinalculate natin yung 176 times 1.20 is equals to 212 volts. So, 211.2 siya. So, niround up lang natin into 212 volts. And sa AC naman, meron tayong 230 na source. So, ngayon, for more efficiency, SPD, so, minultiply natin siya, dinagdagan natin siya ng 1.20%. O yung, dinagdagan natin siya ng 20%. So, 230 times 1.20 equals to 276 volts. So, ito yung mga kailangan nating SPD rating para sa ating solar power home. So, dito naman sa solar power home grid type 0 bill, so, ginamit din natin example is yung 300 kilowatts per hour. So, ayan. So, divide lang sa 30. So, 300 divide 30 magiging, so, meron tayong 10 kilowatt hour a day. So, convert natin into watts. So, magiging 10,000 watts a day yan. Then, yung peak sun hours na sa Pilipinas is, ayun nga, nilagay natin dito is 5. So, 10,000 watts divide 5 is equals to 2,000 watts. So, ngayon, or kailangan natin, mas, hindi naman kasi accurate to. So, nagdagdag tayo ng around 10% ulit para, ayan, additional, ano lang, dahil di naman accurate lahat ng solar panel natin. So, 2,000 times 10%, so 1.1, so equals 2,200 watts. So ngayon, 2,200 watts, ang ginamit naming rating sa aming solar panel is 100 watts. So i-divide lang natin yun. So 2,200 watts divide 100 watts equals to 22 solar panel. So ito ang kailangan namin solar panel, 22.
22 panels para ma-zero bill. Hindi kailangan.
Para magkaroon ng zero bill.
Ngayon, meron na kami sample sa current arrangement namin. So, kalahati pa. So, ito yung mga magiging parte ng aming solar panel. Ito, papakita ko na. Ito. Ito nyo naman dito. No? Magiging part siya na solar panel na nandito nga. Which is connected to mga solar rails na di ba lang ano itsura. Pero alam ko yung mga railing siya para steady siya sa roof. May mga, siguro may nails doon, may mga screws, ganun-ganun. Next doon yung circuit breaker, yung surge protection device, inverter, may limiter din yung inverter, some programmable timer dahil minsan hindi mo naman alam kung kailan mo bubuksan yun, hindi mo naman kabisado ng oras, time delay switch para hindi magka-surge, AC surge protection device, may isang AC circuit breaker din, at hanggang doon na dahil di kasama yung panel board. So doon naman doon, may mga yan, may clamps, may mga gano'n. Tsaka syempre wires. May wires pa pala ba? Hindi naman wireless yung kuryente. So doon, tsaka yung ideal orientation ng solar array. Since the Philippines is above the equator, then the array orientation commonly regarded as the direction in which The solar panel's face of the areas in the areas in the northern hemisphere of the country must be facing the south direction. Hindi east, south. Dahil above nga tayo ng equator dahil mas magandang sa array.
Next is the solar panel roof installations. This is the needed parts, how to install the solar panel in the roof of the house. This is the needed parts, the solar panel. Obviously, the first is the solar panel. Solar energy begins with sun solar panels, also known as PV panels. Are used to convert lights from the suns, which compose the particle energy called photons, into electricity that can be used to power electrical loads. The next is the wiring. Kailangan din natin siya para yung electrical wiring diagram will outline the size that and length of wire needed for your project. As for the copy of your wiring diagram to source materials from your local hardware stores. Then next is the junction boxes and splices. Use insulated lugs or other improved splicing device, or no wire nuts for DC splices. The next is AC disconnect fuses. Is a conventional connections that backfeeds the grid will require a non-fuse manual AC disconnect. This may be included with your system. Check the parties on your quote and order forms. The next needed parts is the PV meters. If you install a grid-tied system, your utility may require a dedicated PV meters to measure productions coming from the solar array. The next needed parts of the solar panel roof installations is the conduits and meters. The NEC or the National Electric Codes require the solar wiring to be transitions to conduit before leaving the array EMT or the electrical metallic tubing is required unless otherwise specified. Next array.
Ikaw sa
This is the ideal roof orientations in the Philippines. The first is the face your solar system toward the right directions. I-face daw natin yung ating solar system to the right directions. Since the Philippines is above the equator, then the array orientations commonly regarded as the direction which the solar panel faces of the areas in the northern hemisphere of the country, which the facings the sound directions. On the other hand, regions in the southernmost hemisphere should be facing the north directions since it is the regions that is nearest to the earth equators. But you don't have to remember all this. You could just instruct your installer to follow your roof instructures. The reasons for this is because most houses in the Philippines is already have their roof built to face the east and the west, both of which get a significant amount of sunlight. This is the ideal roof orientations in the Philippines. Yung sa circuit breaker rating naman. Dito sa DC circuit breaker, yung rating niya is 11.53 ampere. Kung paano nakuha yan, ito yung computation yung computations. Yung 9.22, yun yung max direct ay DC current. Tapos ita-time siya sa 125% para sa DC circuit breakers. Kaya lumabas yung 11.53 amperes. Kaya nga may sinusundan tayong diagram, kaya ang gagamitin natin ay yung 15 ampere. Tapos yung circuit breaker rating naman, yung AC circuit breaker rating naman is on the AC sides, let's assume that inverter rating is 1 kilowatts and the current of 12 amperes is multiplied natin daw siya sa 125%. That is 15 amperes. Kaya ang i-use natin siya, yung use natin sa ating circuit breaker rating is yung 20 ampere circuit breakers. Is the circuit breaker DC. Yun nga yung iwan tayo kung ano ating kung yung MCB ba or yung plug-in circuit sa isang circuit breaker or sa direct DC circuit breaker. Kung yung plug-in ba o yung MCB type. Ang napili ko ay yung plug-in circuit breakers because is a specified type of miniature circuit breaker which has main feature of the easy installation by using a special type of electric panels that is designed for it. Plug-in MCB are normally available for voltage below 600 volt and frequency of both 50 Hz and 60 Hz. Ito naman sa ating AC circuit breakers, ang aking napili naman yung para ma-install yung MCB types because the AC circuit breakers is sub-qualified in two types. The low voltage circuit breaker and the high voltage circuit breakers. The circuit breakers whose values lies below the 1000 volts is known as the low voltage circuit breaker and above 1000 it is known as the high voltage circuit breaker.
Thank you all for listening to our video. We are happy. Thank you all for watching and listening. Like and subscribe. This is the group of mine. The leader of me, of course, M.Gonzales.
And I'm A.AdorDionisio.
I'm A.Tarucan.
And I am I.Centeno.
And goodbye. Ayun. Goodbye.
Thank you.